Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syedakhmal bin Syed Jamalil. I am from Faculty of Electrical Engineering, University Malaysia Perlis. Now I'm doing my PhD under my supervisor, Associate Professor Technologist Dr. Muzamil Isa. And first of all, I would like to thank you, the organizer of EREKA 2022, for giving me the opportunity to present my project here. So I am presenting detachable PCB Rogowski coil current sensor for partial discharge measurement. And we already get the UK copyright here. And here is my PCB design. And here is my team members. Okay, as we go to the presentation outline, I will give the explanation on each sections. First will be the introduction, the problem statement, objective, scope, methodology, results, and so on. And here is my team members in the pictures. Here is my supervisor, Professor Madya Dr. Muzamil Isa, and here is my co-supervisor, IR Dr. Zaidi Abdullah, and Dr. Ayub Nayan. Here is the technician, Mr. Azman, who helped us in the high voltage lab. And for the introduction, a little brief about what is the PD. It is a localized dielectric breakdown caused by the voids in the HV electrical insulations, and if it left undetected, it can eventually lead to the full breakdown of the insulation system. So we need to design a RC current sensor on the PCB that can help reduce the chances of the irregularities and the short circuits. So the PCB also have many advantages, including the what we call it ability to measure the wide range of current from milliamps to megaamps, the low cost equipment, and many more. So here it is the problem statement. First, we designed the PCB RC because of the previous sensor have an inefficient typical sensor because the sensors are bulky and costly, and the designs requires substantial wiring, so we have to design the new one to overcome all this problem. And the second one is because of the noise interferences. As we can all know, the wide bandgap semiconductor technologies can overcome these problems, so we have to design using the PCB to cancel out the noise interferences. Maybe it can reduce the noises if we are not using the substantial wiring. And the third one is a low sensing capability. So the previous typical sensor have a low sensing capability, and with our equipment, our sensor, so we can overcome the low sensing capability. Okay, and here is the objective of my projects. First, we have to develop the PCB Rogowski coil using a detachable. Why detachable? Because for the easier installation in the site, and we can bring the equipment to any locations, so then we can measure in any locations. The second ones, we have to evaluate the measurement results between the HFCT, high frequency current transformer, and with our equipment PCB-RC. So we have to compare with the two results using the experimental impulsor HB through the 11 kV XLPE cable. And the third one, to determine the PD characteristic based on the data set of measurement on the high voltage cable. So there is a limitation in our projects. These experiments we conduct under the standard of IEC 60270, which measures PD pulses in the frequency below 1 MHz, and the system is appropriate for laboratory measurement only, and but we can use in the site, in the real site. The standard measuring frequency is below 1 MHz, and the PCB-RC is built to support the bandwidth of 500 kHz to 50 MHz. And here is the methodology of my project. First, we have to calculate, we have to design using the appropriate formula. So we have to design the diameters of the PCB Rogowski coil, how many turns. So for this one, we have make the 50 turns Rogowski coil, and then we have to design the PCB-RC using the online software EasyEDA. Then we fabricate on the PCB, and then for the measurement testing, we have to compare the HFCT with the PCB-RC that we have designed. So here is the experimental setup for the measurement. So here is the HV, what we call it, HEFLI, HV construction kit test set. So it produced the HV supply, and we put HFCT on the cable, and we put a PCB-RC that we designed on the cable like this. Okay, so this is the PCB-RC that I designed, and this is the HFCT, the previous equipment tester, and the result will be recorded using the LeCroy wave support oscilloscope. So here is the results. As we can see, on the red line is the PCB-RC result, and on the blue line is the HFCT result. As we can see here, the PCB-RC data have the high positive amplitude compared to the HFCT by 42.91%. And in terms of voltage sensing, the PCB-RC current sensor provides a higher sensitivity because of the PCB eliminates the probability of the error. And same goes with the 4 kilovolt measurement testing. We can see the PCB-RC also have the higher amplitude if we compare to the HFCT in the blue line. And for this second experiment, the PCB-RC is proportionally higher by 42.86% compared to the HFCT signal. Therefore, the larger the PD pulses sources has been detected, the greater the amount of the sensitivity will be detected. And for this presentation, I only show the result of oscilloscope of the measurement sensitivity. There are many other data points, the results that we collected, but we are not presented here for the convenience and for the time. And here is the commercial potential of our projects. We can collaborate with the NB Research and government bodies like Jabatan Kerja Raya, and we already make a collaboration with the leader cable industry Berhad and the Southern Cable. And for the publication, we have produced one publication in international conference on emerging electrical energy, electronics and computing technologies, hosted by UniMAP in 2021, last year. And we already managed to get a copyright from the UK Copyright Service. And for the conclusion, the PCB-RC current sensor will continue to be relevant in the future, especially with the development of more power electronic systems that use the wide band gaps technologies. There are still issues. The noise must be reduced more, and the noise under investigation must be reduced to the wide harmonic noises. The pulsating interferences, which is significantly more difficult to operate due to their resemblance to shape and the frequency spectra of the PDs, must be investigated. Means that we have to analyze using the MATLAB. And here is the suggestion. There are many software that can use to analyze the PD characteristic, but some of that we are using the MATLAB. And the PCB RC sensor also must come with the complete convenience analysis tool, because for our measurement now we have to using oscilloscope. Maybe in the future we have to combine the more convenient analysis tools with the PCB RC sensors, so they have any they still have any space to develop in our projects. So with that, I would like to thank again to EREKA 2022 for giving me opportunity to present in this prestige event. Thank you very much.